So I have the pleasure of introducing Jean-Baptiste. He's presented at SMPTE Toronto before, however, this time he's presenting remotely from Belgium. So it's like 1:30 a.m. his time. So definitely a great appreciation for him to call in and do this presentation for us. Jean-Baptiste joined intoPIX in 2007, a company creating innovative image processing and video compression solutions for cinema broadcast Pro AV applications. He leads intoPIX product and business development. With the recent JPEG standardization, he participates in the design of new AV workflow and devices. Jean-Baptiste is active in different standardization committees and industrial alliances. He holds a business engineering master's degree from the Leuven School of Management in Belgium. And due to the lack of natural ice in Belgium, he also likes to play hockey, but on grass. With that, I'll hand it over to Jean-Baptiste.
Thank you, Lee. Can you hear me correctly? Just to make sure everything is running.
Sound is good. Video good.
Thank you. So I'm glad to introduce you to JPEG XS, and in particular for live production in LAN over the WAN and in the cloud. First, we see three key trends in live production. The first one is probably the one that we've been very busy this last couple of years. So this is the move from SDI to IP, essentially within OB-WAN and facilities with the standardization of SMPTE 2110. The second trend is the trends to move data and not people. This is particularly true these days with the COVID. So we see more and more remote production. We want to have more connected facilities to reach economic benefits, resource sharing, both technical and human, and reducing travel. We also see big trends in using COTS and cloud in a real-time production chain, with first higher speed interface becoming more affordable in LAN. It was an easy move to 2110 with uncompressed, but also with cloud providers working their offering, providing transport integrity between their own processes. But the uncompressed data rate are really massive. If you think about HD uncompressed, it's 2.4 gigabits per second, 4K 69.6 gigabit per second, and if I just mention 8K 60 or 8K 120, you see that this is really massive. So within a LAN, uncompressed can be realistic, but within a wide area network transmission, it's not really the best option in terms of cost. So what if we could replace uncompressed, easily managing more pixel over the existing available bandwidth that we have, while safeguarding the low latency and pixel perfect quality. That's really the focus of JPEG XS. How to manage more pixel, save cost and power, preserve quality in low latency, and simplified connectivity. These new standards, in fact, XS, just to start with, the XS means extra small and extra speed. The initiative started in 2016 with a call for proposal. Selected, and if you are familiar with the TICO SMPTE RDD 35, an evolution of it was proposed and was selected as a design, and we have done a collaborative work ISO JPEG committee. That's all. Today you see really JPEG XS solution available from technology provider and from manufacturers and first deployment as well. So we could say that it's the most advanced standardized lightweight codec today. Sorry. Yeah, so the next question is where can JPEG XS be implemented? In fact, JPEG XS can be implemented everywhere uncompressed is currently used. So it targets not only infrastructure, but it also targets devices. It targets IP production, remote production, but also cloud processing and storage. Automotive, such as ADAS system, where you have more and more video, connectivity between a chip. If you have a limited bandwidth, just to connect two components between, or within a display or within a mobile phone, if you need to reduce memory transfer, interconnectivity as well. In VR, AR headset for wireless transmission, 5G wireless as well. We did some experiment a year ago with JPEG XS and 5G, and also AV over IP, which is a big trend in the Pro AV, like typically KVM or video distribution within enterprises. So it really addresses application where uncompressed is not realistic and latency and complexity are critical. So if you have more pixels to manage, if you want to reduce internal video bandwidth and power, if you want to build an efficient hardware and software-based ecosystem, as I said, without affecting the quality. So to create a JPEG XS standard, we took a different approach. While older compression traditionally focused on, as a first value, on the bandwidth efficiency, how much can I compress, we took the approach to create a codec where latency, quality, and multi-platform efficiency and complexity would be the most important factors. So that's if you look at the graph, you see clearly all different JPEG XS is from traditional distribution codec like H.264, HEVC, or different it is from intra-frame codec as well. So regarding the quality, if you try to replace uncompressed, we had to define really demanding testing process. So we have been using a new methodology that is an ISO standard for near lossless quality assessment. We selected a set of natural content and synthetic content as well. And it's what we did, it was the subjective assessment, so a flicker test where one side of the screen was the uncompressed content, and the other side of the screen we were interleaving the uncompressed content with the compressed content, and we were doing that after 7 encode decoding on the uncompressed content. So that in that test, we were not only just looking at how robust how the quality was maintained, but also how it was maintained after multiple encoding decoding passes. And the flicker test is somehow the most demanding testing you can do, because you interleave the uncompressed content with the compressed, and your eyes will be very sensitive on these temporal change in the video. So what we did is we analyzed that down to 3 bits per pixel on all the set, which is approximately a 10:1 compression, and without seeing any loss of quality. But pushing forward this kind of testing, or if you don't do the flicker but you do side by side or other, or if you use less demanding content like natural content, film, TV content, we have observed that we were able to compress much more than just what was made by that experiment. Also, we look at the degradation, which is something also important. What kind of artifact the JPEG XS codec could produce if we would use it out of its operating range. If you want to compress more, let's say if it's not the main feed but just a monitoring feed, you could decide to compress it in a more aggressive way. So in JPEG XS, you will get a smooth degradation, no blocking artifact, because it's also a codec that is based on a wavelet transform, like a previous JPEG 2000 codec, for example. So multi-generation means that you decompress multiple times, and just the PSNR will remain the same across these multiple encoding, decoding. So we also look, and that was a constraint from the call for proposal of JPEG XS, not only to meet the expected quality, but also to meet the expected minimal complexity, targeting multiple platforms, so both hardware and software platform. So JPEG XS is really the smallest codec for FPGA at that efficiency today. So what our experiment at intoPIX is, we have been able to fit several FPGA design for customer with a lot of encoders, decoders fitting in the same chip. We have within JPEG XS multiple profile for lower power, lower logic. We have a very low internal buffering because the compression only use a few lines of buffering to compress the frame, while other intra-frame codec typically will need to store one or two frame to write and read in a memory. If it's interframe, you have the GUP, so which impact both latency and complexity also. So the story is very different with JPEG XS. In the key requirement, we had to meet expectation to fit, for example, on specific Xilinx device or Intel device, 4K 60 frame per second encoders, decoder, and these devices are somewhat bit low cost. So JPEG XS high speed in software. In the design of the algorithm, we took care to have an optimal syntax offering various degree of parallelism to be optimal when it has to target a GPU architecture or CPU architecture. So it can exceed regular editing codec performance. And from observation we did, it's 5 times to 9 times faster than the JPEG 2000 ISO standard. So JPEG XS really offer best trade-off between cost, power consumption, and quality. And because I think that was also requested by the previous presentation, I wanted also to share the latest advanced that were done in CPU implementation during the COVID. So from the numbers that were shared to the industry previously, we now reach a really significant speed in CPU in just using a 6-core Intel Xeon here. You can see that we are really close to 8K 60 frame per second, or we could support up to 10 stream of HD 60 or 3 stream of 4K 60 using a 6-core, and the encoder is very symmetrical. So this is really promising, and I would not say that these numbers need to be taken as they are. It's as they are today, but the JPEG XS standard is quite new, and future implementation and future improvement can still be done. So, but you see that it's on a 6-core CPU. The performance are quite amazing. minimal latency Also at that level, I would say that on the FPGA, we've been sharing that for JPEG XS a lot. So for hardware device that we can reach less than a tenth of 1 millisecond, so 0.1 milliseconds. So typically it's like 10 lines to encode, 10 lines to decode, but you can, depending on the profile that you are using. On a CPU, also, you can reach just few lines of latency, so you can go far below 1 millisecond for a full encode plus decode in CPU. So we know that a human can detect a latency only above 13 milliseconds, and I would say you could cascade a lot of JPEG XS encoding, decoding without perceiving any latency. But of course, you have to take into account a lot of parameters in the live production. It's not just the latency of the codec, it's also the latency of the interface network that need to be taken into account. So JPEG XS is designed also to be future-proof, so there is somehow no limitation in the resolution. Chroma format, it supports 444, 422, 420, monochrome, and we are even working for future profiles supporting raw Bayer compression. In terms of bit depth, it can go from 8 to 16 bit. HDR is supported. There is no limitation in frame rate. And an interesting feature is also it's the internal scalability of the codec. So somehow the proxy is part of the XS master. So JPEG XS has a multi-resolution flexibility. It can offer two additional level of resolution. So to give you an example, if you have a 4K video stream, or as illustrated here, 8K video stream, you could decide to just decode the 4K resolution of it or the HD resolution of it. When you do that, you will easily build a monitoring system consuming less CPU resource or GPU resource, but you can also use some transcoding application to move from a proxy to an H.264 resolution for format, for example, to go over a limited network or something like that. So JPEG XS also is an ISO standard, so it delivers open specification, ensuring interoperability. But an important work has been done also with other standardization committees and industrial organization. Today, JPEG XS is published as a standard. We work on future profiles like the raw Bayer compression, some extension from matte lossless 420, or things that are somehow not highly demanded for IP production, but that could be useful for other areas. The RTP specification of JPEG XS has been done and is in final review. It relies on the SMPTE 2110-22, which is the encapsulation of compressed video for SMPTE 2110. We also specify MPEG transport stream encapsulation, MXF format, MP4 format, and even HEIF format, the same container used by HEVC, if you're familiar with that one. So what we mean with bandwidth efficiency in HD, 4K, and 8K? If we take the typical bandwidth at the best quality, we would typically target 3 bits per pixel. So this is the upper limit that you see here for this resolution. But depending on the context, the content, you may want to compress a bit more. We did some experiment at intoPIX, typically for 4K at about 750 megabits per second, 8K depending on the size of your 8K screen and the content. We did a demonstration at NAB a year ago of 8K at 2 gigabits per second. Of course, the screen was so small that it was not really easy to distinguish some noisy artifact. But it just showed how powerful can be the compression standard. So what is interesting also is that if you consider existing infrastructure, of course, we know that high bandwidth infrastructure in LAN are possible, but Cat5e cables are very accessible. In my laptop, I can connect a gigabit feed. So it's important to look at JPEG XS also as an enabler to use simple Cat5e or Cat6 cables. So moving forward, live IP production with JPEG XS can enable to connect a remote production, can enable to move your workflow to cloud production, can also enable to be used in a LAN within some facilities that want to optimize the number of stream, upgrade to feature resolution, be in access through a gigabit network. This really offer a huge huge benefits for live production at that level. So in the LAN, you can target cost-effective infrastructure, cheaper cables. You can reduce storage cost, as you can also record your file in XS. You have a friendly bandwidth for PC software. You don't need to redeploy wires if you have a Cat5e or Cat6 cables. Over the WAN, it offers cost effectiveness with 10 times a smaller bandwidth. It will offer reduced IP packets. It will ease the remote production, the contribution. And in the cloud, it offers very efficient CPU performance, but also GPU and FPGA. And all these three platforms are somehow available with a very low latency. So it's really enabled to overcome the uncompressed limit, preserving all the benefits of a compressed also, such as quality, latency, and you get somehow more value by using JPEG XS. So my takeaways is like JPEG XS offer a true alternative to uncompressed to connect to the cloud, the WAN, and run in the LAN. It preserves the quality. It offers software firmware upgrade capability to new formats in existing infrastructure, and it guarantees interoperability thanks to the use of open standard and specifications. Thank you.